f of x equals 2 over x plus 1. G of x is x over x plus 1. And I want to know what f plus g is. Now, if you remember, this is the same thing as saying f of x plus g of x. So what I'm going to do is I'm going to take these two functions, f, and I'm going to make f red, and g is going to be blue. So I'm going to get f. So this is going to equal f, which is 2 over x plus 1. And we're going to add that to blue, which is going to be x over x plus 1. Now, to make sure everything works out, you might want to put parentheses over the whole functions. If I put these together, it has a common denominator, so this is going to be 2 plus x over x plus 1. Now, the back of the book has this. X cannot be negative 1, which I don't understand why they need it, mainly because it's obvious if I plug in a negative 1, it's not going to work, but they put it there, so I'm going to put it there too. The next one is going to be, this is the same thing as f of x minus g of x. I can do the same thing as just putting x here and x here. And so you get f of x, which is going to be 2 over x plus 1, and then minus x over x plus 1. Now in this example, the parentheses don't do anything, but if you had like a polynomial or something up here, you need to make sure that this negative gets distributed to the whole thing. That's why I have parentheses here. So what I need to do is I need to distribute this negative up to here, which makes things a little easier. So this is going to be 2 minus x over x plus 1. Now remember, you cannot reduce these, mainly because these are adding, and this is dividing, and adding and division don't undo each other. And so this is my answer, except I need to put x cannot be negative 1. F times g. So this is the same thing as saying f 2 over x plus 1, and this is when parentheses are really detrimental, x over x plus 1. And then I end up getting 2 times x, which is going to be 2x, over x plus 1 times x plus 1, which is x plus 1 squared. And here, once again, x cannot be negative 1. F over g of x is going to be 2 over x plus 1 divided by x over x plus 1. And like we knew before, in order to reduce this, we just need to flip and multiply. So this is the same thing as 2 over x plus 1 multiplied by x plus 1 over x. This now reduces with that, and you end up getting 2 over x. But you got to put, okay, so x cannot equal 0 from our answer, and then x cannot be negative 1. This is important. This one you actually have to do, because if you notice that this actually reduced, which means my restriction went away, but it really doesn't go away. You still cannot plug a negative 1 into my answer. So there you have it.